Okay, let's just do some more work on creating and analyzing graphs. Let's look at creating a table and a graph from context, okay? From a real world problem. It says during the first 6 weeks of summer, the number of bored children triples. Okay, so there's our keyword, triples. It says during the first week of summer, one child was bored. How many children are bored at the end of each week for 6 weeks? So they want us to do a table for 6 weeks. All right, so we need to determine our x and our y, our domain and our range. All right, so we're going to look at week 1, 2, 3, 4, 5, 6. All right, that's going to be our domain because we cannot change time, at least not yet. All right, so we're going to label. We're going to label, if I can get rid of this, there we go. We're going to label the bottom here weeks. And then on our range, we're going to have the number of bored children. Okay. All right. So on week 1, they had one kid that was bored. And then it triples. So 1 times 3 is 3. Times 3 is 9. Times 3 is 27. Times 3 is 81. And times 3 is 243. Okay. All right, so we've got our table there. We've got our number of weeks and our number of bored children. It says the local librarian would like you to create a visual aid to compare these data with her charts from last year's boredom data. Create a graph to model this year's number of bored children per week. All right, now I've noticed this on some of the stuff that's being turned in. When you're making a graph, these numbers that you're going to put on your axis, they need to be in the same increments. All right, so if I'm going to number it like 1, 2, 3, they're one apart. I can't go like, let's see. I can't say 1 and then 2, 3, 5, 4, 5, 6. Okay, I can't do that because there's not the same amount of units between each of the segments. All right, so you have to make them equal. All right, and since we're only looking at 6 weeks, I'm going to kind of spread this out a little bit. So I'm going to go every 2 units. So 1, 2, 3, 4, 5, 6. You've noticed I've got 2 units between each digit. Okay?
Miss Crawford.
All right, number of bored children. I've got 1 child up to 243 children. Okay, and it goes 1, 3, 9, 27, 81. All right, so that I can get the 250. Let's see if I do 25. Let's see, that would be 1, 2. Okay, what if I did 25 this way? 250, 75, 100. Okay, let's do every 2 is about 20. 2, 4, 6, 8, 100, 120, 140, This would be at 160 up here. It's far a long ways between 250, isn't it? All right, so let's try something else. What if we, instead of skipping, let's just say this is 2, 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, 220, 240, 260, 280, 300. Okay, that's a little bit better. All right. All right. So for one child was bored the first week. So week 1 we had one bored kid. All right. And since one of these units is 20, we're going to stay down in here for a little bit. All right. Week 2 we had 3. Week 3 we had 9, so we're almost halfway. And week 4 we had 27, so this is 20 and this is 40, so we're going to be about right here. And then it's going to be about right here. Week 5 we had 81, so 6, 7, 8, so right over the 80 mark. And then week 6 we had 243, so we're going to go all the way up here to 220, 243, so about here. All right, so we've got, this is going to be as we knew it would, since it's multiplying each time, it's exponential, right? And the reason it's staying right along in there is because we're approaching 0. Okay? All right. Yeah, make sure that your units are the same amount. Okay? You might have to play with it a little bit to see how you're going to number them. But you need to make it equal, and you need to make it spread out enough where your graph makes sense. All right? I wouldn't want to crunch this all down in here, and it would end up like almost looking like a linear line. Okay? All right, let's look at the next one here. Okay, Jerome currently has a bag of 75 pieces of hard candy at noon. He plans to eat 12 pieces an hour, as he studies. How many pieces of candy will Jerome have at the end of each hour from 12 noon to 6 p.m. when he takes a break for dinner? Well, he's not going to feel like dinner after all that candy. All right, so we're going to do our table first, and then we'll create our graph. So our X is going to be our time in hourly increments. So we've got noon, which is when he started. So this is term 0. And then 1 o'clock, 2, 3, 4, 5, 6. Okay, so he originally started at noon, so that's our 0. 1, 2, 3, 4, 5, 6. All right, and we're going to start off at noon with 75 pieces of candy. All right, so Y is going to be pieces of candy. All right, the number of pieces we have at that time. All right, so he started off with 75, and he's eating 12 pieces. So minus 12. So this is going to be linear because we're doing the same thing every time, right? So 75 minus 12 is 63. And then minus 12 again will give us 51. And minus 12 is going to give us what, 39. Minus 12 is 27. Minus 12 will be 15. And minus 12, he's going to leave us 3 pieces of candy at 6 o'clock when he breaks for dinner. So he's going to have some candy left over. Alright, so now we're going to come over here and label. So again, let's week 1, 2, 3, 4, 5, 6. And we went from 75 pieces. So let's just label these 10, 20, 30, 40, 50, 60, 70. Oh, that's 75. Comes out perfect. Okay. Alright, so at noon, this is noon, at 0, he had 75 pieces of candy right here. That's also our y-intercept, isn't it? He had 0, 75. Alright, at 1 o'clock, he had 63 pieces. So we go up to 60, to 65, so it's almost 60. It'll be about right here. And then at 2, he went to 51 pieces. So we'll go up to 50, just past that, it's 51. And then 39, so almost 40. And then 27, so 25, 26, 27, so about halfway in between there. And then 15, so 10, 15 here. And then at 6 o'clock, he had 3 pieces left, so he's right here. Okay, so you have a linear, and this, there's not an arrow here. We've got an end point and a beginning point. So we've got a maximum here and a minimum since it's real world, and we've got an ending point. It's not an arrow that goes on. Okay, so that's when you have a linear that can have a minimum maximum because it's real world. They have a starting and end point. Okay. All right. Making predictions based off of a scatter plot. So this survey was taken asking employers the number of hours employees worked on average and the rate at which employees quit after a year. The result of the survey is shown in the scatter plot below. Although a survey did not include data for 50 to 60 hours a week, so right here, that's why we have that blank here, 50, 60 hours worked a week. Make a reasonable prediction about the turnover rate at a 55-hour week job. All right, so 50 and 60, so right in the middle, in between. So let's just go up. So we're going to be somewhere in this area right here, right? So I would say a good estimate would be a turnover rate of 50. Okay, if you want to kind of go up a little bit more, so I'd say between 50 and 55 would be a good answer. Okay. And let's see. Let's look at this one. It says your best friend's brother Chester is working at the mall to buy your sister a necklace for her birthday. He will start off making $7.25 per hour, and he's expected to work 12 hours a week. If the necklace costs $391.50, wow, pretty nice necklace. Make a prediction about how many weeks Chester will have to work before he can afford the necklace. All right, so this is going to be weeks, because I want to know how many weeks. That's our X. And then this is let's see, let's put this the cost of the necklace. You want to do it that way, or, well, we can do this way. This is the amount he made. Okay, so week 1, he's making $7.25 an hour, and he's going to work for 12 hours. So first, you're going to find out how much he makes a week. So if you multiply that, you're going to get $87 a week is what he earns, right? All right, so week 1, in 1 week, he'll make 87. And then week 2, he's going to add another 87, right? So that's going to be 174. Week 3, he makes another $87. So that's going to be 74, 261. Then he makes another 87. So that's going to be 348. Then he makes another 87. So it's 435. And then okay, so how much? I'm going to keep on going, but he only needs 391, right? Well, after his paycheck on week 4, he doesn't have quite enough money, right? So he's going to have to go and work another week, and then he'll have plenty. Probably, maybe you'll have enough to pay the tax too. Okay, so I would say about 5 weeks. Okay. Now, some people might say, well, 4.5 weeks, but you're not going to get a check till the end of the week. So you got to work out that full week. Okay. I mean, if he got up and quit, then yeah, 4.5 weeks, but we're going to say that he keeps working. Because it seems like she's high maintenance. Well, it depends on how old they are. Okay, so much on that. Let's see. These are pretty simple. All right, if you want to, you can go ahead and work these two for practice, and then I have you a few problems to do to turn in. Okay. All right, y'all have a good evening.